Do you want to learn how to make your own PIR sensor based GSM alarm system using Arduino? Then watch this tutorial from start to the very end. Hi guys, my name is Fahad and welcome to Electronic Clinic. If this is your first time here and you want to learn Arduino programming, PLC ladder logic programming, SCADA application designing, SolidWorks, Visual Basic application designing and programming for microcontrollers to send and receive data, Android, security systems, robotics, image processing and much more. Start now by subscribing and clicking the bell icon so that you never miss anything. Welcome back my friends. As you know, today's episode is about the PIR sensor based GSM alarm security system. In this episode you will learn how you can protect your home, office, etc, etc, etc. First of all, we will cover the PIR sensor, then the GSM SIM900 module, then we will study the complete circuit diagram, then we will make relay module, then interfacing, then programming, and finally the testing. So let's get started. So my friends, this is the PIR, which stands for the passive infrared sensor, and this is exactly the same one as you can see on the screen. So let's start with this variable resistor. This one is used for the sensitivity adjustment, and the left one is used for the timing on period delay adjustment. So you can simply increase and decrease the on period delay, and you can also increase and decrease the sensitivity adjustment. So as over here you can see these pads labeled with L and H. Well, actually these are used for the single cycle mode and for the retrackable mode, stay on while motion detected. Okay, and now this IC, which you can see is BISS0001, which is the signal processor. And over here you can see these are the pins. The leftmost is the 5 volt, middle one is the out, and the rightmost is the ground. So over here you can also see this is the 5 to 20 volts and output TTL logic, and this is the ground. So it doesn't matter whether you give 5 volt or 20 volt, it has a 3.3 volt voltage regulator, so it will convert that into 3.3 volts. Product parameters: number 1, detection angle of 120 degrees, number 2, detection range of 7 meters, and number 3, its size is 32 into 24 millimeter, and number 4, TTL switch, which is a transistor logic switch, signal output high, signal output 3.3 volt, and low signal output, which is 0.4 volts. It means when an animal or human is detected, so it will give us 3.3 volt at the output, and when there is nothing it will give 0.4 volts. And number 5, the trigger time is adjustable from 0.3 seconds to 10 minutes. And number 6, commonly used in anti-theft devices and other equipments. And number 7, modules have been forced to set work reusable trigger. And my friends, one more thing that I want to share with you. Actually over here you can see these 2 holes and the RT is written over there, and there are 2 more holes and the R is written over there. So this portion is for the LGR. So if you want to use this for the LGR, like for the night and day detections, or like you want to make a decision on LGR, so then you can remove the PIR sensor and use an LGR over here. This is the GSM module that we will be using today. It's SIM900A. This is exactly the same GSM module that we will be using today. This is SIM900A, and it has all the pin informations. As you can see, all the pins are labeled. You can see these 2 pins will be used for powering up the GSM module. We can give 4 to 5 volt to power this on, and well, the ideal voltage is 4.7, but we can give it 5 volt as well. And this is the ground pin, and as you can see, so we'll be using all 3 pins: the ground pin, the RXT 5 volt, and the TXT 5 volt. So the RxD is the receive pin and the TXT is the transmit pin. As you can simply use a SIM over here, and this is SIM900A module. You can also use SIM900D, and then after this I will tell you how to interface this GSM module with the Arduino, and I will also tell you about the circuit diagram, and we will explain in detail the programming. So let's start. If you are from Pakistan or India, first of all make sure that you purchase the unlocked version of the SIM900A. If you're using SIM900D, then using that module you'll be having no such problems. So first of all, make sure when you purchase this SIM900A module, you should ask that whether this particular module is locked or unlocked, so that you don't purchase the wrong version. If you purchase the wrong version, it will be blocked automatically. Using SIM900A is very easy. All you need is just to use a SIM card. Over here you can easily open this, use a SIM card, and then over here we'll be using only the 3 pins which I told you, which are the ground, the TXT pin and the RxD pin. So the TXT and RxD pins will be connected with pin number 7 and 8 of the Arduino, and the ground pin will be connected with the ground pin of the Arduino. And as you can see over here, there's a DC socket, and this will be used to give 5 volts to the GSM SIM900A. So friends, you will also be needing Arduino Uno. If you don't have the Arduino Uno, you can use Mega as well, but currently I have Arduino Uno, so that's why I'm using this one. In simple words, we can say that any program which is written for the Arduino Uno can be run on Mega, but the reverse may not apply, because in Mega we have so many input output pins. So there's a possibility that the program which we have written for the Mega may not run on the Arduino Uno. So if we end up in a situation like this, then what you will do, you will just simply change the pins in Arduino Uno, and then you are ready to go. So my friends, this is the complete circuit diagram of the GSM alarm system using PIR and Arduino. And we have already discussed in very detailed about the SIM900A and about the motion sensor, but let me tell you once again that you can give 4.7 volt to 5 volt to this GSM module, while some modules have voltage regulators and that can be powered up using 12 volt and 2 ampere adapters as it needs like more amperes. And now as you can see that the TXT of the SIM900A will be connected with pin 7 of the Arduino, and the RxD will be connected with pin 8 of the Arduino. As you know my friends, that the Arduino Uno has only one serial port which is available on pin number 0 and pin number 1. So the pin number 0 and pin number 1 will be using that for the debugging purposes. So then we will be needing another serial port for the GSM module, as it will be doing a serial communication with the Arduino Uno. So for that we can use a software serial library. If you want to learn in very detail about the software serial library, so you can watch my tutorial on the software serial library. So for now I just want to tell you that we will have to make another serial port for the SIM900A using the software serial library, and that will be available on pin number 7 and pin number 8, which I will tell you in the programming. And the ground of the SIM900A will be connected with the ground of the Arduino. And now PIR motion sensor. So the VCC will be connected with the 5 volts of the Arduino, but if you want you can also power this up using an external power supply. You can give it from 5 volts to 20 volts, as it has a built-in voltage regulator which is 3.3 volt regulator. And the out of the PIR sensor is connected with pin 2 of the Arduino, and the ground is connected with the ground of the Arduino. So make sure that you keep only one ground in the entire circuit, so all the grounds should be connected with one another. And now let's have a look at the relay driver circuit. So the relay driver circuit consists of a 2N2222 NPN transistor and a 10K resistor, which I will tell you in a couple of minutes how to design the circuit and how to select a particular transistor. and this is the buzzer, which is one side of it is connected with the 12 volt and then the other side is connected with the normally open of the relay, and the common pin of the relay is connected with the ground. So when the relay is turned on, this contact will connect with this one, so the path will be closed and the buzzer will on. So what it will do, when it will detect an intruder, it will give a signal to the Arduino. Then what it will do, it will turn on the buzzer and also send a message to the owner that an intruder is detected in that particular area. So if you can see over here, the emitter is connected with the ground, the collector is connected with one side of the coil, and the other side of the relay coil is connected with 12 volt, which I will explain once we will be doing the soldering. So that's the complete circuit. If you have any question, you can let me know in a comment and I would love to answer. So my friends, let's start with the relay module. So my friends, first of all, let's start with the components that we will be needing for making our own relay module. If you want, you can also use a ready-made relay module, but if you want to learn how to make your own relay module, how to find pins of an SPDT type relay, how to perform the relay driver design calculations, then you should definitely watch this. And so let's get started. So let's start with the 2N222 transistor. The leftmost leg is the emitter, the middle leg is the base, and the rightmost is the collector. We also gonna be needing a 10K resistor, a DC socket which will be used to power up the relay module, a Vero board, and an SPDT type relay which has 5 legs, as you can see. So this is the common, these two are the coil pins, and this is the normally closed and this one is the normally open. Let's start with finding the legs of the relay and then we will perform the design calculations, and then after that the soldering. So let's start. So my friends, this is the SPDT type relay, which stands for the single pole double throw, and this is the schematic symbol of the SPDT type relay. And we know that it has 5 legs, as you can see clearly, 1, 2, 3, 4, 5. It has 5 legs, and out of these 5 legs, the one is the normally closed, the normally open, and common, and 2 are the coil pins. But actually we don't know, as over here there is no information about the coil pins, about the normally closed, normally open, and common. So first of all, we will find the pins that which one is the normally closed, which one is the normally open, which are the coil pins, and which is the common pin, because we have to find these pins. Because if we don't know about the relay pins, then how we can perform the relay driver circuit design calculations. So for the design calculations, we need to find the pins. So let's start. So my friends, for finding the relay pins, we will be using this digital multimeter. So first of all, set this on 2K and turn this on. So first of all, we will start with finding the relay coil pins. So for that, we will check all these pins, so one by one. So first of all, check these 2 pins, and you can see there is no resistance. So check this one with this one, with this one, like this, and no, and now this one with this, this one. Okay, now this one and this one. Yeah, we got resistance. So my friends, these 2 are the coil pins, and let's confirm again. So connect one terminal with this leg and one with this, and you can see the resistance is 0.433. So here is a coil, and R is equal to 0.433 kilo ohms, which is equals to 433 ohms. Okay, so now we have the remaining 3 legs, this one, this one, this one, and now we have to find that which one is the normally closed and which one is a normally open. So for this, set the DMM on the continuity. Okay. So now my friends, we have these three legs remaining which we have to find. So this is the middle one, actually the middle one, this one and this one. So we have to find that which one is a normally closed, which one is the common, and which one is a normally open. So now one by one we have to check all these three pins. So first of all, connect this with this one. And with this leg. So there is no beep sound. Okay, now connect this with the middle and this one. There is no sound, and you can hear that there is a sound. So it means that this is normally closed and this is normally open and this is the common. So the middle one is the common, and as we are holding it like this, so when we hold it like this, this one will become the normally closed. So this is the normally closed and this one is the normally open. So that's how we can find the relay pins. So now let's perform the design calculations. We have already found the resistance, and now it's time to use a formula, and for this the formula is V equals to IR, and as we know that it's a 12 volts relay, so 12 equals to I multiplied into N. The resistance we have already found this, so 433. Now the current will be equals to 12 divided by 433. So my friends, we get this value, which is 0.027 amps. So let's convert that into milliamps. So it will be equal to 27 milliamps. So now from this value we have to decide that which transistor actually we have to use. So as I'm using an NPN transistor, so I will search for an NPN transistor. So a type of NPN transistor whose collector current is greater than 27 milliamps. So you can find on the internet, like there are thousands of NPN transistors, but you have to select the one which is easily available in the market, which is cheap. So I recommend that you should always use 2N222 transistor for the relay driver circuit design calculations, because this type of transistor is easily available in any electronic shop, and its collector current is greater than 600 milliamps. So this is like perfect transistor for the relay driver circuit design calculation. It's really cheap. So now it's time to start the soldering. So let's first apply some solder to the red wire and then apply solder to the black wire. Now we will connect these two wires with the DC socket. So first of all, apply some solder so that we can easily connect. So first of all, we will solder the black wire, and now we will connect the red wire. So as you can see, the wires are soldered. This is the DC socket, and now we will connect the terminal block, so with which then we can later connect an alarm or a DC load. So we will solder the pins, as you can see. Okay, now the soldering is done for the block terminal. So now apply some silicone on the relay. And now you can see. So now we will solder the 2N222 transistor. So you will solder the legs, and make sure that you don't apply too much heat, because it can damage the 2N22 transistor. So the soldering is done for the 2N22 transistor. Now we will connect a 10K resistor with the base of the 2N222 transistor. Here you can see the legs. So now apply solder, and again don't apply too much heat, as it can damage the electrical components. So now we'll connect this yellow wire with the 10K resistor. The wire is connected. Later we will connect this wire with pin 13 of the Arduino Uno. Now we will apply some solder to two black wires. So the one wire will be later connected with the ground of the Arduino, and the other black wire is coming from the DC socket, and we are connecting this with the 2N222 transistor emitter pin. So as you can see, now the red wire will be connected with one leg of the relay, which is the coil pin. So it doesn't matter which side you connect this. So one side of the relay coil will be connected with 12 volt, and the other side then will be connected with the collector of the 2N222 transistor. So over here we are connecting the red wire, which is coming from the DC socket. And now you can see the red wire is connected with the relay one coil, and the other wire is connected with the 2N222 transistor emitter. And now this other side of the relay coil will be connected with the collector. So solder this wire, and now the other side will be connected with the collector. So as you can see clearly, this wire is coming from the relay and will be connected with the collector of the 2N222 transistor. So now let's solder this. Now let's apply some solder to the wire, and also to the other side. Take another wire and apply solder to both the ends. Now we'll connect these two wires with a terminal block. So one wire is soldered, and now solder another wire with the other leg of the terminal block. Now solder these wires with the normally open and common pins of the relay. So now we connected this green wire with the common of the relay, and now the blue wire will be connected with the normally open of the relay. So my friends, you can see all the soldering is completed. The DC socket is connected, the red and the black wires are connected, and this wire will be connected with the Arduino ground. So that's it. Now our soldering is complete. The common is connected, the normally open is connected. So friends, as you can see, all the components are interfaced. This is the SIM900A. Its TXT and RXT pins are connected with pins 7 and 8 of the Arduino, and its ground is connected with the ground of the Arduino. And this is the DC socket, and over here we will connect this 5-volt adapter. So okay, and this is the relay module, and the yellow wire is connected with pin 13 of the Arduino, and the ground wire is connected with the ground of the Arduino. This is the PIR sensor. Its out pin is connected with pin 2 of the Arduino. The ground is connected with the ground, and the VCC is connected with 5 volt of the Arduino. So the interfacing is completed. The connections are 100% as per the circuit diagram. And now I will connect Arduino with the laptop. Now I will start the programming, and once the programming is completed, then I will upload the program, and then we will test the circuit. So let's start the programming. So my friends, this is the program written for the PIR sensor based GSM alarm system. So let's start with the hash include software serial.h. So make sure that you start with this line, as we will be making our own serial port on pin number 7 and pin number 8, as the Arduino serial port will be used for the debugging purposes. So it means that we will be needing another serial port for the GSM module, as the GSM module will be doing serial communication with the Arduino. So we are defining a serial port on pin number 7 and pin number 8. So we are using software serial SIM900 and pin number 7 and 8. If you want to learn how to use the software serial.h library in details, you can watch my tutorial on the software serial, how to make multiple ports. Now, as we will be sending a message to the owner when an intruder will be detected, so for that we will be needing a string a message. So we are making a variable text for SMS of the type string. So the text for SMS will be used to store the message. Integer PIR sensor. The PIR sensor will be connected with pin 2 of the Arduino, and integer relay equals to 13. So the relay will be connected with pin 13 of the Arduino. Later with this relay we can connect an alarm, or we can connect a load. My friends, as you know that every Arduino or Mega program has at least two functions. The one is the white setup and the other one is the white loop. So the white means that this function is not returning any value, and the empty parentheses means that this function is not taking any argument as the input. So let's start with the serial.begin 9600. We activate the serial communication for the debugging purposes, and then we also activate the GSM module at a baud rate of 9600. It's serial.println when the logging time completed. So if you don't include this line, it doesn't matter. Then pin mode PIR sensor, which is an input device, and pin mode relay, which is an output device, and then we keep the relay in off state by default. And then we wait for about 5 seconds so that the GSM module can stable on the network. Then we start the white loop, and if digital read PIR sensor is equal to high, so this instruction means, this condition means that check if there is anyone in front of the PIR sensor, check if the PIR sensor has detected any motion. Then what to do? Text for SMS equals to intruder detected, then digital write relay high, turn on the relay with which an alarm is connected, or a light bulb is connected. Send SMS, text for SMS, then just send the message. And serial.println text for SMS, this is I'm using this one is for the debugging purpose. And serial.println message sent, and then delay 8,000 milliseconds, which is equal to 8 seconds. And if digital read PIR sensor is equal to low, if there is no one in front of the PIR sensor, this simply keep the relay in off state and just wait for the 1 second. And white send SMS. So when this function is called, then the compiler jumps over here, white send SMS and string message. So SIM900.print 80 plus CMGF equals to 1. 80 command to send SMS message, like it is just to select a plain text mode. So then delay 1000 millisecond, which is equal to 1 second, and SIM900.println 80 plus CMGS. So then send this message on this number. This is my cell number. So if you want, you can also send me a message on WhatsApp. So delay 1000 milliseconds, which is equal to 1 second, and SIM900.println message, the message you want to send, which is this message, the intruder detected. And then SIM900.println corrected 26, which is equal to AZ, the ASCII code for 26, and delay 1000, then SIM900.println and delay 100. So that's it. You can download this code from my Blogger page. I will provide the link in the description. You can download all the circuit diagrams, the codes, all the pictures, each and every detail from my Blogger. So my friends, as you can see, all the components are connected. As you can see, the SIM900 module is already connected with the network, as the LED is blinking at a slow rate. And so now let's start the checking. So as you can see, the relay is activated and the LED is also on. And now let's wait for the message. And as you can see, I just received a message saying that the intruder is detected. So I will put my hand in front of the PIR sensor and let's see. As you can see, the relay is activated as the LED on pin number 13 is high. And now let's wait for the message. And as you can see, I received a message that intruder is detected. And now again the relay is off. As you can see, the LED on pin number 13 is off. So now let me do it again. As you can see, it detected the motion. The LED on pin number 13 is high, the relay is activated, and now let's wait for the message. So I hope you liked today's episode. Like my video, share my video with your friends, and see you in next episode, and thanks for watching.